The second law of thermodynamics states that entropy increases in a closed system. This video explores a more precise question. What happens locally in an open system when energy is continuously transformed and deliberately exported? This is not a proof. It is an experimental model, a set of observations, and a hypothesis. In this model, water is not irradiated. Water serves exclusively as an energy source. It drives a turbine, generates electrical power, and supplies a laser operating in continuous mode. The object of investigation is the water after energy extraction, compared to an untreated control sample. The system is open. Energy enters, is transformed, and leaves the system. For the total system, the second law still applies. Entropy does not decrease globally. However, local entropy reductions in subsystems are permitted, provided they are compensated by the environment. The working hypothesis is simple and conservative. Local order may increase within a subsystem, while total entropy continues to increase overall. On a microscopic level, this could correspond to altered molecular correlations in the water. This hypothesis is open and falsifiable. The experimental setup is intentionally simple. A constant water source drives a turbine. The turbine powers a generator. The generator supplies a laser in continuous operation. There is no direct interaction between the water and the laser beam. In addition to classical measurements, qualitative structure phenomena were documented. The images shown are based on a freezing-based visualization method. This method does not produce quantitative measurements. It generates visual patterns only, which are evaluated descriptively. Differences in symmetry, fragmentation, and repeatability were observed and documented without causal interpretation. A central feature of this model is the direction of energy export. The laser beam is deliberately directed away from the system, symbolically into space. This reflects a general physical principle. Open systems stabilize through continuous energy emission. Stars and planets exist in radiative balance. They absorb energy and emit energy, primarily as radiation. This emission is not merely a loss mechanism. It is a prerequisite for long-term stability. This model does not claim equivalence, but proposes an analogy based on shared thermodynamic structure. Earth itself is an open thermodynamic system. Climate change can be described at its core as a persistent imbalance between incoming and outgoing radiative energy. From this perspective, climate stability depends not only on energy input, but also on how energy is transformed, redistributed, and emitted. This model does not propose a technical intervention. It proposes a conceptual lens. The results presented here are qualitative and exploratory. They are not statistically validated and allow no causal conclusions. This work is not a solution. It is a question posed carefully within established physical principles. If stability in open systems emerges through structured energy emission, then understanding emission may be as important as controlling input, from laboratory systems to planetary climates.